Traveling in space to the moon or the planet Mars has long been a topic of fascination to people everywhere. Traveling through space requires the expertise of scientists and engineers and the skills of machinists, welders, electricians, and software technicians. Above all, these experts must take the knowledge and skills they possess and add creativity to the mix to develop ideas and strategies for achieving long-distance space travel. In this globally networked curriculum project, students will be challenged to design a space habitation module which addresses at least one of the major design challenges facing NASA engineers today. Students will work in groups to research, design a solution, produce sketches and 3D models, build a prototype, and ultimately present your solution to a NASA engineer. Students will have the opportunity to meet with and interview a NASA engineer via Skype each week so they can learn more about the challenges facing aerospace designers and ask questions along the way as they develop their own solution and then synthesize that knowledge with the design process to develop a solution. The learning leaders for this GNET project will be the classroom teacher and a NASA engineer. The NASA engineer will provide content-specific knowledge, answer student research questions, and evaluate the students' presentations. The classroom teacher will oversee the day-to-day aspects of student research and prototype development and will provide a final grade based on the rubric collaboratively with the NASA engineer. The students in this course are 8th graders with an average age of 13. 90% of students speak English as a second language. Approximately 5% of the students have IEPs with accommodations primarily for ADHD and autism spectrum disorder. The target content outcomes are assessed in two primary ways. First, students will be assessed on the authenticity of their solution and the quality of their presentation by the NASA engineer. This assessment will be in the form of a rubric assessment of the design itself with written feedback notes. The second form of assessment is a final rubric grading by the classroom teacher, which will evaluate all deliverables, the prototype, and presentation based on design process requirements. Students are formatively assessed on a daily basis throughout the project through progress reports and evaluations that the group is required to submit. The desired cultural outcome is improving student confidence when learning and presenting in English. This will be monitored by checking for understanding after the Skype meetings with the NASA engineer, checking for understanding of goals and objectives, and by encouraging students to develop fluency and confidence by adequately preparing for when they need to read or speak in English in front of an audience. The collaboration and communication outcomes are monitored by teacher observations each day and completion of a short rubric based on those observations during student group work. Students receive a group work score daily so that they can continue to work and improve on their interactions and take responsibility as a group. Students receive a final grade based on their overall performance in the areas of collaboration and communication as part of the classroom teacher's final rubric grade. The 21st century skills assessed within this project are problem solving, critical thinking, and collaboration. The problem solving skill is assessed through application of the engineering design process and will be assessed as part of the rubric evaluation. The critical thinking skill will be assessed through evaluation of the team norms, notes, question the team asked the NASA engineer, and based on the documentation of their research. The collaboration outcomes and assessment is addressed in the collaboration section on the previous slide. To begin this project, students will have a whole class Skype meeting with the NASA engineer. Students will be given the opportunity to ask relevant questions and get needed information from the NASA engineer. Students will then begin using the research from the NASA engineer and additional sources to begin brainstorming their solutions using the design process. Students continue working through the design process and have access to the NASA engineer via email and additional Skype meetings to clarify as needed and get feedback. During this phase of the project, students will generate design sketches, 3D models in Autodesk Inventor, and build prototypes. To complete the project, students will prepare a professional presentation which contains all design process deliverables such as design briefs, sketches, 3D models, prototype pictures, and design notes and annotations. These documents will be used by the NASA engineer and the classroom teacher to score each group's projects. Students will receive daily assessment and final assessment from their teacher using a basic design rubric that evaluates collaboration, 21st century skills, and application of the design process. Students will also receive a final assessment from the NASA engineer that is a rubric score for their projects and feedback notes based on the NASA engineer's overall observations of the students' research, design, and presentation skills over the course of the project. This project is structured so that additional students in classrooms around the world can participate through facilitating the same projects, participating in the Skype activities, and sharing final presentations. The more classrooms participate, the better the student experience overall. The project will also benefit from additional aerospace engineers and designers to provide more perspectives and facilitate student questions in Skype meetings. More access to experts improves the student knowledge base and research experience. To join this globally networked curriculum project, please email me, Crystal Purvis, at crystal.purvis@scienceandtech.org.